So it is. I hope it is in recording mode. Uh, so as I stated, we have already learned the operating system. So it would be easy to go through this course. This may be considered as an extension of the same, because Unix, we are going to focus on Unix or Linux, which is a huge case of operating system. So overall knowledge we have already acquired, what exactly the operating system is, what are roles and responsibilities, how it works. Okay, so those are the things we have already learned, and now we'll be seeing that how exactly those things are done in the Unix or the Unix or in Linux environment. Okay, so basically we are going to learn about the internals of Unix and Linux, so that we should have more knowledge. One may ask, sir, why we are going to learn about Unix and Linux, why not Windows? So one should be knowing that Windows is not open source. So the all codes and operating procedures are not available in the open market. However, this Unix, specifically Linux, is developed by the you may say academics community. So if you know a little bit, industry is more oriented towards enterprise edition, because the objective of the industry is to make revenue, to generate revenue. And the objective of the academia is to serve people, make world better. They are not very focused towards the revenue. So they are more concerned about the revolution, ease of doing the things. Okay, by keeping in mind that everything is known to other, so further successor may take the things forward without any hurdle. On the other hand, whatever development is done by the industry, they basically hide it from rest of the world. They just make utilization for their own purpose, and basically they make use of those developments to generate more and more revenues. So there is a trade-off. This is coming from very beginning. From industry side, there is some other effort. Those are known as enterprise effort, and on the other hand, academia is making some effort, which is basically based on the open source. Okay, it doesn't mean that industry is not making any effort for open source, but yes, if you look into the internal things, they are basically not in favor of developing open source systems or the software, because they are making an expenditure on that, and they want to make encash the same. Okay, so just refreshing your knowledge about the operating system, since Unix and Linux is a huge case of operating system. So we are first of all defining the operating system. It is not difficult because we have already learned the course. Same definition, I have kept it here for your reference. Just I am reading it, that operating system can be defined as a collection of system calls working as an intermediary between system, hardware, and user. So we have already seen the what is called a layered architecture of the operating system, or layered architecture of Unix also. So what we have seen, that there is a core, and in the core, what it remains? It remains the hardwares, and on the hardwares, some we are making some programs on top of that which can interact with the hardware. Those programs which can interact with the hardwares are known as system programs. Okay, and in operating system, it is known as system calls. So the hardware is in the core of the layer architecture. Then we have kernels. Sorry, kernel means collection of system calls, and then we have shell, and then we have applications. Some users are interacting with the system through shell. Some users are interacting with applications, user specific applications. So these are applications are basically developed for the purpose of user convenient, by keeping in mind of user convenient. Shell is, on the other hand, given prompted to the end user so that it can avail kernel services directly. Kernel services are prompted to end user with the help of the shell. However, we know that difficulty is that we have to know about that, the which shell I am using, and accordingly we have to remember the commands. And if we know the commands, then we can interact with the system to get our job done. So you can say here that the operating system has a full control over the hardwares or the system resources. These hardwares are known as, in terms of system resources. System resources are also represented in terms of memory, CPU, input output devices, and all. So you can just straight away just read operating system has a full control over the resources such as memory, CPU, monitor, and keyboard, and offer its services to the end user as per the convenience of the end user. If you want to know more about that, I just wanted to tell you that every resource must have one controller attached with that. CPU has CPU controller, memory each device have their own controller, monitor controller, keyboard controller. And generally what happens is that the instructions comes from the CPU towards the controller of a specific device, and then the instructions are interpreted by controller, and controller makes sure that the instructed job is performed by a specific resource or a specific device, and accordingly results are stored in memory. So generally it is stored on the CPU registers, and there onwards, if permanent storage is required, we keep it in the secondary memory. So this is how operating system basically interacts with the controller of each device and manages every device with two basic key points that we already know, that it should be easy and convenient for the end user and efficient use of available resources. Otherwise, if you want to make use of a system hardwares in a random, unmanaged way, then our work is not done in a desired manner. Just for an example, if I want to print a document, you have also given a print command. I have also given a print command. Somebody else has given also the print command. And all jobs are there in the printer queue. But printer controller takes and execute those instructions in a one by one manner. So there is some control mechanism. Otherwise, what will happen? In a single page, some content of yours, some content of mine may be intermixed with each other. So that is known as unsynchronized use, or it may lead to chaos in the system. So the system's hardwares are completely under the control of the operating system, and operating system manages all those resources and gives the services to the end user, as if end user may think that these resources are reserved for me, but same resources may be utilized by n number of processes. And these are all done in an organized way because operating system daemons are working. So these things are already known to us. We have already seen seedling and all. So these are known to us. We also know that these three objectives of every operating system. One is efficiency means efficient use of every hardware. Okay, so it should be shared among multiple processes, and it should provide a convenient way through which end user can interact. Okay, so end user should not find very difficult while giving its instructions to the system. So operating system must be designed in such a way so that it should keep in mind about the user convenience. And the third one is the flexibility. So you may give instructions. If immediately it is not going to be executed, then operating system may take that instructions and may give results later on, but you need not to be there in the controlling those activities. So operating system itself will take care of that, and then the output is generated and may be stored in some files. Later on, you may prompt to see that the outcome of a specific program or like that. Okay, so this sort of flexibility is also offered. Now we talk about the examples of the operating system. So here is few important examples of the operating system. UNIX, which is, you may see among these examples, the UNIX is most oldest version of the operating system. Then we have come up to Linux, Mac OS, and then Windows. And to be very frank, many students are confused that Unix and Linux both is same. But no, both are not same. Unix, if you look into that, Unix is developed for enterprise use. However, Linux is used for enterprise as well as open source. Both versions are available. But Unix, definitely it is an enterprise operating system. Okay, we will do more discussion over that. But yes, you need to develop that. The Unix is oldest one, developed in 1969. Linux 1991. Just see the gap. There is a huge gap. One is in the era of 1970, other one is 1990. So there is a 20 years of gap. After that, Linux come into the market. Mac OS, you may be knowing about that the Apple iPhone, Apple laptops that they make use of Mac OS. This is another version of operating system or another example of operating system. And then Windows is a very popular, so we all know about the Windows. Okay, moving forward, these are the services offered by an operating system. I should not focus more on that. Just I'll be reading and stating the program execution. Okay, so in what order program should be executed, how the successful program execution should be achieved. Okay, so that is the job of the operating system. Then input output operations. User wants to feed some data in the computer or a program, then operating system must provide a way that how user can feed and read or get the data from the system. Then we have file manipulation system. File is basically used for data storage. Okay, but yes, after the storage, we also need to look into the other aspects like how the file is going to be accessed by different types of user. Okay, so maybe in a system 5 users are there, and all 5 users may be having different privileges based on their ownership. Okay, so accordingly you can manage the file to give or to offer different privilege to different group of people. We also know that the user can be divided in a different group user. Okay, and accordingly certain privileges may be given to certain group of users on for a specific file. So that also we can do with the help of the chmod command. It may be known to you. Then moving to communication, that how two processes may be on the same machine or maybe on the remote machine can interact with each other. So operating system must provide some API. You know that the socket programming, when two processes are residing on remote computers, they make use of socket, and socket is a part of the operating system. So as I have already stated, the network protocol stack all is implemented as a part of the operating system. So communication is going to be ensured by the operating system. And then we talk about error detection sort of thing. Okay, so it is not only about the network error. Okay, so other error may also happen, like you may be accessing the data out of boundary, so that may be known as memory protection. Okay, or some manipulation you have done in a data manipulation you have done in a wrong manner. Okay, so we apply some checkpoints to see or to validate that the operations are valid or invalid, and accordingly we detect an error, and sometimes we may also roll back certain activity if it is found to be invalid. Then we talk about resource allocation, memory protection, scheduling. So these things are very well known to you. These may be considered as a some main services offered by operating system, including Linux and Unix. I would also like to tell that initially the operating system is designed with a very limited number of system calls. Okay, and those system calls are basically are doing very elementary tasks to offer these services to the end user. What are these? Program execution, input output operation, file manipulation, communication, error detection, resource allocation, protection, scheduling. So initially these things are very elementary and very simple. Later on, it has become a complexity has been included more. Why it was simple? I just wanted to tell that initially when we are putting the data, there is no typesetting or concept of formatted data. We just like we are putting the raw data in the notepad. That way we have to give the data or store the data in a file. So nowadays we are looking for formatted data, that too multimedia data in a single file. You want to include some video, audio, text, and that text should also be in a formatted. So these things are going to increase the complexity of the system, because you have to install some extra utility. You may be knowing that if you need to do need to perform a specialized job, you have to install a specialized application for it, and that way you are installing n number of applications. So your complexity of the system is increasing. In older Linux kernel, there are very limited system calls, They provide only few elementary tasks to the end user. Slowly and gradually, we are going to include some other utility by keeping in mind of user convenient. And nowadays we have moved to operating system having a size of maybe 10 GB. But if you look into the older operating system, the size of the operating system was very small, maybe limited to 200 MB, something like that, 100 MB, 200 MB, like that. Okay, so that part also we discussed. But anyway, first of all, this on this slide we have to focus. This slide is intended to make a difference between the Unix and the Linux operating system. So you just see that what is the main difference. What I have observed is that students normally do not focus on this, and they, when they need to write an answer, they Google it, and then they whatever they find it in the Google, and then accordingly they write the answer. So suppose I have given a question, write a difference between Unix and Linux. Then what I will do? You will just Google and then write, and then your marks will be reduced. Okay, so please be focused on that. So the one of the main difference that we need to understand here is that the first of all, the Unix is an enterprise operating system. However, Linux have both the versions. Linux also have an option for enterprise. Linux also have an option for open source. The second major difference is that Linux is only the kernel. However, Unix is operating system. Please do remember that Unix is full operating system. But what I have find when students write an answer, that they write it in a reverse way. So please be very clear that Unix is a full operating system, However, Linux is only the kernel. Linux kernel, and then we are making it a full operating system like Ubuntu, like Susui. So they are basically made upon the Linux kernel. So kernel of Susui and kernel of Ubuntu may be same. Okay, but the operating system is different. One is OpenSUSE, one is the Ubuntu, other may be the Red Hat. Though the Linux kernel in these three operating system may be the same. Okay, so please try to understand Linux only gives the kernel, and on top of the kernel we add some extra things. Okay, so these are just it is written there also. Everything else means other than the kernel. Linux is only the kernel. Everything else that makes up the full operating system is drawn up from number of sources. But if you look into the Unix operating system, it's not like that. Unix is a full operating system, though Unix is also fractured in a different fractured in case of different flavors. Okay, Unix also have different flavors, that also I'll discuss. Okay, so this is written here, I'll just reading it. By the time Linux first appeared in 1991, Unix had already become quite fractured. Quite fractured means there are different flavor of Unix is also available in the market. What has happened is that the different enterprises have customized the Unix operating system as per their own need. However, two major group is available. One is System V compliance, which has been developed originally in Bell Laboratories. On the other hand, the BSD compliance has been developed in University of California at Berkeley. So these are two majors. However, it is not limited to that. In next slide, I'll be showing you there are different fractures of Unix operating system. Okay, and Unix was developed about in 1969 by Thomson, Kennedy, and Dennis Ritchie. So if you remember, this group of people are also involved in development of C programming. Dennis Ritchie, he has developed the C program, and Kim Thompson. Okay, so these are basically, you may say that these scientists have played a major role while computer system was evolving, especially around 1970s. They have developed C program, they have developed compiler, and they have developed operating system, and their development is still very valid. Okay, because I just wanted to tell you that the system programs are very smart programs because they are a part of the operating system. They must need to be efficient. Otherwise, if your operating system is not ensuring the efficient use of resources, then your application may create more chaos. So that is how the system calls are very smart programs, very intelligent programs. They are developed in keeping a mind of many other things, okay, like performance issues and all. Okay, so definitely they are indispensable nowadays. That is why it is carry forward. Okay, so the programs which has been developed in 1970s, which is still considered to be a smart enough, so that is why it has been considered in a same way. And it is very from the very beginning it was designed to be serious enterprise operating system. So that is why I am giving a focus is that the Unix is an enterprise operating system. From very beginning it is an enterprise operating system. Okay, so I just wanted to remind you also that initially there was no concept of personal computers. So one computer is going to be used by n number of people. So multi-user environment was there from the very beginning. So you may be knowing that the universities are operating with mainframe computers, and that mainframe computers basically may be having several terminals through which the end user can interact with the same computer. And this mainframe computer must have been installed with Unix enterprise operating system. Now, it grew up largely outside the Intel family of the CPU. That means when Unix was going to be developed, it is not developed only for Intel family. You know that the Intel have a large dominance, especially in terms of CPU design. So all operating system normally basically they keep the architecture of the Intel operating system and they design it which may be suitable for it. But as I stated that it grew up largely outside of Intel family, although it was later on it is ported to it. Means it has been supported by the Intel family, but it is not developed based on the Intel family, and it is not only supported by Intel. And it is based on that Linux is based on the x86 architecture, and it is very robust in nature. Robust means even if something goes wrong, then also your operating system is not going to fail. Okay, still it provides you responses. Uh, it is having capability to tolerate some sort of faults even if it is happening in the system. Okay, so that makes the Unix operating system more robust. That is why if you talk about server machines, most of the server machines are utilizing Unix or Linux as an operating system. So Unix server is more preferably in use. Though in case of end user, people are using Windows operating system because it is very convenient for the end user, especially convenient to use. So while end user is using a system, Windows operating system is helping the end user to interact with the machine very easily. On the other hand, the Linux operating system, the user interaction is relatively hard. However, the strength is that even if some error is going to occur, the system itself is capable to respond. So that is the reason why Linux and Unix is more preferably used on the server machine, because what is the thing, the server machine needs to be always responsive. They need to give a service 24/7. However, what happens in case of personal computers? Whenever I have a work, I have just turned on my computer and then shut down. This is not applicable in case of server machine. So server machine has to be robust. Otherwise, if some activity is going on and the machine is taking shutdown, then it may create a big chaos in your system. Okay, so this is how what is the significance of the robustness. Now coming to the development history, that it is Unix is developed in AT&T Bell Laboratories. First version is released in 1961. Predecessor of Unix is multiplexed information computing services. Okay. However, this has not been considered as a full operating system, but yes, before that, multix was used in the computers to control the hardware. Now, user need to access mainframe computers simultaneously. Text formatting and typesetting was included first time in 1971. Okay, so as I stated that we are putting our data in unformatted text file. Okay, typesetting, adjusting the page and all, like the facility nowadays we are having, we are making use of Word, spreadsheet. Okay, so those things was not available in earlier version of operating system. Now 1979 Unix version 7 with 50 system calls. Okay, so you imagine that what is the size of the operating system which is having only 50 system calls. Very elementary services, read, write, store, something like that. So with that, the Unix has been launched, but later on it has evolved over a period of time. More sophisticated system calls are included. Okay, and you just look into that. 4.4 BCD Unix, 110 system calls, then SBR4 system Unix, 120 system calls, Linux 3.2, 380 system calls, FreeBSD 8.0, 450 system calls. So this is how we have increases the number of system calls, and if we are increasing the system calls, that means the size of the kernel is going to increase. So we are going to exploit the system hardware in a more user specific manner. That is why we need to develop more number of system calls. Okay, so system calls provides an option that how basically you can make use of system hardwares. Just for an example, if I have to reserve a memory area, then what we normally write in a C program, malloc, calloc. These functions we make use to reserve some memory area for my program or for my purpose. The equivalent system call is SBRK, that is going to use to reserve some memory space. Because ultimately the hardware unit or the memory unit is going to be considered as a resource or a hardware, and this hardware is under the control of the kernel. and the kernel will issue an instruction with the help of the system call, and equivalent system call is SBRK. Similarly, we write printf, scanf. So the equivalent system call is read and write. Okay, so the way if the number of system calls are increasing, the size of the kernel is increasing, and we are getting more sophisticated way to use the system resource, or more specialized way, or more option that how we can make use of the resource. So this is how the size of the kernel has grown up from 50 system calls to maybe nowadays we may be having 700, 750. By 1993, most commercial vendors changed their variants of Unix to be based on System B with many BSD featured added. Okay, so then they have considered based of all these two fractures, and they have tried to make it as a more convenient operating system, and they also have made a try to make it a standardized one common operating system, a standardized version which is acceptable by all the vendors. Some vendor specific versions of Unix is stated here in this slide. Just see, SGI is one vendor or a company which has developed UNIX, which is equivalent to Unix operating system. Sun Microsystem, you may be knowing that Sun Java. Sun is an old company. Okay, so it has developed its own operating system, Sun OS or the Solaris. That is just a variant of Unix operating system. Similarly, IBM is another vendor. So it has developed an operating system X. So this is a different, you may say, the fracture of a flavor of Unix operating system, vendor a specific version of Unix operating system. HP, HPUX, Cray, Unicos, DEC, Ultrix. Each one of these manufacturers often had several varieties running even on its own universe of hardware. SCO was only SCO was one of only variants not arising from hardware company. So SCO was not one company driven, which is having a specialized hardware. Anyway, so these are just discussed about different fracture of the Unix operating system. Okay, so maybe a bit boring because we are talking about the history. Okay, so this history we need to know because this adds interest in our work. Okay, now coming to different variants, as we have already discussed here, while there were various efforts to achieve some standardization, most vendors had strong self-interest in keep the things proprietary. Okay, so if the then vendors have made their effort for the development, definitely they will try to make it a proprietary version, and they just wanted to encash it. But there were always two major flavors which has been considered, which already stated in the second slide also, System B and BSD. System B, Bell Laboratory, BSD, and another laboratory that we have stated here in this slide in the University of California and Berkeley. Okay, System B, Bell's Laboratory, BSD, University of California at Berkeley. So these two versions are very popular. Okay, applications or they have become the different vendors, they are trying to be either compliant of system B or BSD. So they are making some changes in their operating system to become system B compliant or BSD compliant. Application developers interested in portability had to uh, use of this other things like macros and all has been included. Now, even when the APIs were not that different, the actual implementation could be radically different from platform to platform. Basic kernel architecture also differed. Each platform had its own set of basic file utilities, sales, and etc. So what I mean to say is that there are some utilities which differs from one version to another. Okay, sometimes some system calls are also different. Okay, in different flavors. Okay, but if you talk about the GNU version, Free Software Foundation. Okay, so this is basically GNU stands for GNU, not UNIX. Project developed freely distributed version of many basic utilities such as tar, ls, grep, etc., and even more important to GCC compiler. Now, what I mean to say is that since every flavor is using their own version of basic utilities these are example of basic utilities such as tar, ls, grep, and etc. Now, what GNU has done is that this may be considered as one standard. So they have given a standard version of utilities, and the every version is supposed to, if you are GNU compliance, then you must adopt the GNU standard utility. So there should be a common flavor between different versions because you are GNU compliance. Okay, so the same flavor is available with all fractured operating systems. So this attempt has been made. Otherwise, the problem is that maybe one enterprise operating system may be working in one machine, may not be working in another machine. Okay, so there is some gap between the hardware design and the operating system that you are installing over it. So it has attempt has been made to standardize, and so that the users should get the same sort of flavor. Otherwise, the user also become confused while using the operating system. Like if you are using Ubuntu, then you have to use a different sort of commands because you are using different cell. Okay, and if you are using some other like OpenSUSE and it is having different cells, so you have to interact in a different way. X window is also different. The desktop, I'll be teaching you the desktop, which is basically responsible to responsible to feel and touch activity. How basically you feel when you are using the operating system, like Genome and all. You may have seen while installing the Linux operating system, it asked for two desktop manager, sometimes Genome, sometimes KDE. So Genome and KDE is basically taking care of look and feel of a system, of your system. Okay, so these things have been tried to standardize. Okay, otherwise different fractured, and then the user will be very confused. Okay, Why? Using the machine, and machine to machine, it has to struggle while getting the functionality or the while processing the data. Suppose I am sitting in my machine, I am very comfortable with, but when I sit on your machine, then I become it becomes tedious for me to do my work. That should not be. So that is why standardization makes simplify and a common way of interacting the thing. So that is why JNU has made an standardized effort to make a common utility, and that should be adopted by all the flavors. Okay, so moving ahead, these are some other correlations between Unix and Linux. Just go through it, correlations, and that is what I'm going to stop. But yes, I'm giving you some time to ask a question. If you have any question, please ask questions. Anything coming in your mind about this course, about this lecture, please be interactive. Now slides will be uploaded on the slides will be uploaded on the MS Team. You just view it from there. I'll be also uploading one textbook. Okay. I hope everyone must have joined the thing. Attendance, I'll take automatic attendance, which is available with the MS Team, and accordingly I'll update in eCampus. No question? Okay, so history was important. I have already discussed about history of Unix, Linux operating system. So with that, I am finishing my lecture. Thank you all. Thank you for your patience hearing. You can leave now.
Thank you, sir.
Thank you.